likelihood methods are more familiar from things like parameter estimation problems, where you have a large body of data and you have a rigorous mathematical model that connects them observations to parameter values, and you're trying to find the best fit to a lot of conflicting measurements. However, you can also use it in a more qualitative situation as long as you can decide whether one hypothesis is more likely than a competitor. The upshot is that even when you have multiple components for a hypothesis, as long as at each stage you are choosing the most likely alternative, by the end of the process you have the most likely hypothesis among the various possibilities. You can't say anything about how likely it is in any absolute sense, or whether it's how much it's more likely than its rivals. You can just say that this is the most likely inference. So the ETI problem, I prefer that to UFOs because of course there are UFOs, anything that you can't identify is an unidentified flying object. But the hypothesis that interests most people is that some of these unidentified flying objects are vehicles operated by extraterrestrial intelligences. And as was sort of implied by my build-up, I'm not trying to estimate the likelihood that the ETI hypothesis is true. My discussion here is, suppose we stipulate that these are extraterrestrial vehicles. What can we infer about the ETI from what's been seen of them? What are the most likely properties? A general principle I'll be using is that the known is more likely than the speculative. If there's something that we know is real, it's more likely than something that we only know is possible. On the other hand, if there's something that we know is possible, that's more likely than something that we simply have not yet proven to be impossible. There is, however, a caveat that applying this unthinkingly will always lead to perfectly mundane explanations for everything, so it has to be consistent with the evidence. Now, reviewing what the relevant evidence is would require a book. Fortunately, Peter Sturrock has written the book, so I don't have to. But this current discussion is based on some very general summary observations. There's a lot of eyewitness testimony, some of it extremely high quality, to things that look like aircraft or aerial vehicles that aren't identifiable with any human culture or technology. There's instrument recordings, videotapes, similar comments. There are somewhat fewer, but some cases of physical evidence left behind. Some of this high-quality witness testimony attests to seeing occupants who sometimes exit the vehicles. When occupants are reported, they're almost always humanoid. They may or may not be described as wearing what appears to be environmental protection. Supposed vehicles in some sightings undertake maneuvers that are well beyond our technical capability. There are some areas of evidence that I am ignoring. I am not paying attention to any reports of voluntary boarding of vehicles by humans or of abductions by vehicles, although it belatedly occurs to me that it actually wouldn't make much difference to my conclusions. One element that I'm disregarding that would make a difference is reports, some of which have been made at the SSE, that ETIs are in fact known to and in regular contact with human governments and pursuing various kinds of clandestine cooperation. The reason I'm ignoring that is that conspiracy theories are not science. In the first place, I would say their intrinsic likelihood of the great conspiracy is very low. It's shared by mutually hostile regimes over decades, while regimes have changed, and yet despite this apparent worldwide overwhelming power, the conspiracy is somehow failing to silence the brave whistleblowers who are trying to expose it. Basically, believing in the great conspiracy is evidence transcendent. Any behavior whatsoever is compatible with the notion that it's due to a conspiracy. However mysterious it is, it's what the conspiracy wants. So it can never be refuted, it is non-falsifiable, it has no place in scientific discourse. Now, I mentioned having multiple components of the theory. Here are the big ones. Do these ETIs have faster than light travel? Do they have reactionless drives? Do they have some form of inertia or gravity control? What can we infer about their biology, and where are they coming from? Well, FTL travel is a simple one. Our current physics absolutely limits material objects to speeds less than light. There are lots of potential loopholes in that, but none of those loopholes have been demonstrated to actually happen in the world that we live in. They are all speculative. So provisional conclusion, unless we are faced with totally incompatible evidence, it is more likely that the ETI do not have FTL travel. Reactionless drives. Now, in virtually all cases, the things that are cited fly around and maneuver. They're not showing jet exhaust, they're not showing rocket exhaust, they're not showing any kind of exhaust typically. And when people get a close enough view to report some details of the object's structure, there's nothing that looks like a rocket venturi or a jet engine. Now, on the other hand, from physics, the third law of motion has not been repealed. According to known physics, you can't accelerate without throwing something the other way. So does the lack of an observed exhaust mean that we have to give that up? And the answer is no. A few years ago, I presented a paper on neutrino rocketry. It remains the case that it is possible to produce a collimated jet of neutrinos that would exert an unbalanced force on its generator, and that is an exhaust that none of our instrumentation would see, and of course our eyes wouldn't either. So since there's also other possibilities, which I'm not going to go into right now because of limited time, but since the evidence does not rule it out, it is more likely that ETI vehicles are using reaction drives. Then there's the question of being able to control inertia or have some sort of internal gravity system to accommodate some of these extraordinarily violent maneuvers. And once again, I'm coming down on the side that we don't have to go to exotic physics, because there are known techniques which are almost at the level of practical application, where you could get humans to survive tremendous g-forces. Basically, the idea is fill up all of your internal air spaces with a liquid of roughly neutral buoyancy, and then to a first approximation, you don't care about gravity, you don't care about acceleration. There will be some limits because muscle and bone and fat aren't all exactly the same density. And at the moment, the big technological hurdle is getting a fluid that can oxygenate the lungs without desiccating them to the point that you die of asphyxiation after the fluid is removed and you try to get back to breathing air. That has been a very frequent problem with test animals in this kind of medium, and that's why it hasn't really been tested in humans yet. Okay, now for biology, the occupants that have been reported, most reports say they're humanoid. They can function in earthly conditions and they don't, while they may be wearing protection, they don't need so much protection that the body shape is unrecognizable. Now here, the evidential value is limited even if the witness testimony is totally reliable. For one thing, a non-humanoid occupant might not be recognized as an occupant. For another thing, the humanoids that have been reported and described could perfectly well be telepresence robots or bioengineered life forms purpose-built for exploration. However, even granted that the value of the observations is limited, it's not zero, so it is at least provisionally more likely that vehicle occupants are water-based oxygen breathers capable of handling Earth gravity. And now, where do they come from? The occupants can function in Earth-like environments. No such environments occur naturally in any other body in this solar system. And that seems to spawn four possibilities. They're comfortable in widely variable environments, or they're from Earth, or they're from artificial habitats in the solar system, or they're from another solar system. Okay. Could they be able to handle any environment? Well, what we know of biology doesn't seem to agree with that. Extremophiles have colonized every environment that exists on Earth, but no extremophile is adapted to all extreme environments. Algae can grow in ice. Thermophiles can grow in boiling water. They don't cross over. So given an organism that can survive typical Earth surface conditions, it is more likely that it will be killed by typical conditions on other solar system bodies. So is ETI really TI? I mean, on the face of it, the most likely explanation for a human-shaped, human-sized being who functions well in Earth-like conditions is that it really is a human being from Earth. I consider this incompatible with evidence, but the evidence in this case is negative. We don't know of any human civilization that has these technical capabilities, and believing that it could be hidden, given how crowded the world is and how much of it is settled and under continuous observation, requires a return to the great conspiracy theory. See a dozen or so slides back. Now, doesn't the evidence also rule out solar system origin? The thing is, unlike Earth, the solar system contains vast regions where a high-tech civilization could flourish without being detected by our current technology. Even in the asteroid belt, which is only 2 astronomical to 3 astronomical units away, an astronomical unit is the radius of Earth's orbit, it's estimated that only about 2/3 of asteroids larger than 1 kilometer have been detected. We've also realized that there's a lot of stuff out in the Kuiper belt at about 50 astronomical units, which is much harder to detect. Then, on the other hand, wouldn't artificial habitats be easier to spot than rocks? And I see that we have some spacing issues here. Sorry. The answer is basically that given the constraints from that a space-going habitat suffers, there are strong reasons to think that it would not be putting out a lot of radiation. It would not be particularly more visible than a natural body, and it might very well be less visible, but I reserve the details for an appendix, which I'll get to if I move fast enough. So an advanced civilization using space-based resources within the solar system is compatible with the observation. Then there's the question of solar or extrasolar origin, and just as a side note, origin here, I don't mean where they evolved, I mean where they're living now. What is the spot from which the vehicles start their missions? Well, the nearest stars are over 250,000 astronomical units away, whereas even a Kuiper belt habitat is only 50 astronomical units away. No matter what their technology is, the longer trip is an enormously greater investment of effort and resources. So the conclusion there is that the most likely hypothesis among those 4 competitors is that they live in artificial habitats within our solar system. Summing up, they do not have FTL travel. They live in somewhat Earth-like conditions. These conditions are artificially maintained in deep space habitats, and they use inconspicuous reaction drives for propulsion. Now, was that the 5-minute warning I just got? Then I have time enough to at least go on to Appendix 1. Some additional inferences. Their civilization is naturally inconspicuous to our current technology. This may be sufficient to explain their non-observation, or they may be intentionally stealthy as well. That's Appendix 2. Okay, I see I should have gone with the PDF form. We do know that they have not chosen to be conspicuous. If they chose to reveal themselves, we'd all know about it instantly. So the policy of the ETI civilization as a whole, therefore, must be either to avoid making themselves obvious or to actually make an effort not to be obvious. And yet, individual vehicles have been spotted, sometimes with multiple instruments and observers, on numerous occasions. The controllers of these vehicles are either deliberately acting in opposition to their civilization's policies, or they are incompetent at carrying out those policies. Hence the slide title, Dissidents or Dolts. It would seem to follow that ETI civilization, like our own, is unable to instill unanimity of purpose or uniformity of skill, even in individuals who have access to significant resources. Now, you may recall from my neutrino rocketry talk that one of the downsides of that drive is that any vehicle using it is a potential gigaton bomb. The implications of having such devices in the hands of ideological rebels or incompetents are not comfortable. I think I've got a couple of minutes. Yes, thank you. So Appendix 2, why would they be hard to see? Okay, we can spot objects in space just generally from their emissions or from their reflection of emissions of other sources. I'm going to assume that there's nothing involved that's big enough to use gravitational lensing. Most asteroid observation is done with visible light, which asteroids reflect but do not emit. IR telescopes can also track things by their thermal emissions. Now, artificial bodies will also reflect and will also emit thermal radiation. However, if it's an artificial habitat for something that likes to live around liquid water, if it's located in the asteroid belt or farther out, it has to be maintaining an internal temperature that's a lot higher than the black body at equilibrium temperature from sunlight at their location. So that means its designers will want to trap radiation, and they'll want to radiate as little waste heat as they possibly can. So the side facing the sun is going to have as low a reflectivity as possible because they want to catch whatever they can. And when they're radiating waste heat, they'll want to use the most efficient heat sink available, which is the 2.7 Kelvin background of the open sky away from the sun, which also happens to be the side away from us. Regarding propulsion, from in-atmosphere observations, we think that they're probably using drives that don't show a visible exhaust. Even if there's something different between in-atmosphere and deep space propulsion, the kinds of rockets we're accustomed to are very inefficient. I mean, the glare and the shine doesn't add anything to the thrust. So an optimal reaction drive is going to be tightly collimated. It's going to be extremely internally cold. We're not going to see it unless it hits something. Similarly, talking, we're using broadcast radio all the time. We're also all living on the same planet. The farther you have to send a message, the more inefficient it is to broadcast. Whatever technology they use for signaling, they're almost certainly using tight beams that we'll only see if we happen to be in the beam path. Now that's just the natural considerations for a space-based civilization. What if they're actually hiding? That would imply that they're even more careful about their signaling and drive beam paths, and they're going to make an effort to make sure that nothing points at anything where somebody might see it. Now, why would they be hiding? Just going through this very quickly. It may be that they don't want to damage us. It may be that they think we're dangerous. We can rule out the possibility that they're hostile. If they wanted to get rid of us, they could immediately. And thank you. I'll now take questions.
Thank
I
you.
won't
You're
point at
really
anybody
interesting
because that's
talk.
the moderator's privilege.
Yes. Right, Peter.
Thank you very much. York. I'd like to make two comments. One is, I think it's helpful to distinguish...
Hold the mic closer.
Okay. It's helpful to distinguish ordinary physics from extraordinary physics. And if you consider extraordinary physics, then of course considerations about time of travel and resources have become irrelevant. In this context, one should also bear in mind reports of objects appearing out of nowhere and then vanishing, suggesting that we live in a very complex space-time. Okay, all right. One should consider extraordinary physics, possibly involving other space-time manifolds. The other point I want to make is that analysis of databases show a strong relationship to local sidereal time, and that points towards origin outside the solar system.
My response to that, sorry, I forgot for a moment that I didn't need that mic, is that with regard to extraordinary physics, of course, it is very easy to explain things by invoking extraordinary physics in terms of a likelihood analysis. I felt compelled to stick with the principle that known physics is intrinsically more likely than extraordinary physics unless observations are completely incompatible with known physics. Regarding sidereal time correlations, I will simply note that a Kuiper belt habitat is going to have a longer orbit than Pluto's, which means more than 2 to 3 centuries, which means that a single origin point somewhere out in the Kuiper belt would only have moved across a small patch of sky in the time we've been making observations.
Thank you for your stunning use of logic. That was really interesting. Regarding the propulsion force, probably you're familiar with all of these lifters that are on the internet. We have one in the lab. You just attach 2 wires, 2 conductors on a lightweight frame to 10,000 volts, and it lifts like a genie. And ours lifts up about a meter or so, but I've seen some of them lifting up 5 or 10 meters. Is this a possibility? It's very simple. You just need a high voltage source, and I suppose if these are developed further than what the hobbyists have been able to do, you could get substantial lift out of that.
Possible electromagnetic drive mechanisms that interact with the atmosphere or the Earth's magnetic fields are among the possibilities that I glossed over for lack of time. So yes, that's certainly plausible.
Hi, York. Known physics, to you and all of us, I think now, includes the ability to shift subtly the probabilities of events. Is it possible that they got here and travel by an improbability drive?
I'm afraid I have to class that with extraordinary physics, mostly because experiments in parapsychology show that there is some sort of disconnect between the probabilities of relatively infrequent events like bits being processed and the probabilities for elementary interactions. Pear showed a 1 in 10,000 probability shift from RNGs. If I can do a 1 in 10,000 probability shift in molecules, I can slam that door and hold it shut against a battering ram. We don't see that in the lab.
York, regarding conspiracy theories, I think Richard Nixon said that you're not paranoid if they really are out to get you.
The converse of that is that even if they are out to get you, paranoia is still unhealthy and dysfunctional thinking.
But more seriously, if the extraterrestrials are hiding their presence, isn't that a kind of conspiracy theory?
No, because I'm not postulating that there's a human conspiracy that has somehow managed to infiltrate every major government on Earth while still hiding itself. If they're hiding, they're way out there where they're hard to see.
Okay, well, thank you very much, York. Good presentation.